This is the third of 3 videos reviewing the concept of area and volume. In this review, we're going to look at 3 real AP problems from the past to give you some idea of how College Board in the past has tested the area of the concept of area and volume. However, throughout the years, they have evolved the way that they ask these particular questions, but this gives you some idea of ways that they have asked these questions in the past. So let's begin by reading the prompt. Of course, let R be the shaded region bounded by the graphs of the square root of x, y equal e to the negative 3x, and the vertical line x equal to 1, as shown in the figure, in this case, to the left. So over here they have already provided, so one thing you can see that they do is sometimes they provide us with the graph that they're talking about. So we can see that we have the graph of e to the negative 3x right here. We have the graph of y equals square root of x right here. And we have x equal to 1 right here. Now those 2 radii are what I drew in to do part B, but let's begin with part A. Part A indicates that we're to find the area of region R. So we're going to, this is calculator active, so we're going to go to our calculator and we're going to create that graph. Actually, before I do that, let me clear my screen here and get rid of these functions that are already in my calculator. So before I do that, let's just kind of make a plan looking at the graph that they've provided. If we're going to find the area of region R, hopefully you can see that we're going to do a top minus bottom. That makes more sense. Note they did not say in terms of x or in terms of y, so we've got to analyze this situation and decide what makes the most sense. So if we put little man in there like that, we can see that there is a top and a bottom. So let's get rid of that. Clear those annotations. All right, and so if we're going to find the area doing a top minus bottom and we're going to be in terms of x, then we're going to need to know this point of intersection, and we know that the upper bound is going to be 1. We can see that. So we're starting here at this value of x and we're stopping here. So the calculator is going to need to find that point of intersection for us. So that's one of the things that we're going to need to find. So I'm going to go to the calculator. I'm going to put in the 2 functions that they gave me. So y1 is the square root of x, and y number 2 is e, and there are a couple of places you can find the e. Right above the ln button is a good place to find that, and that was e, I believe it's to the negative 3x, yes. E to the negative 3x. And if you, well, we do need to take a look at that. I'm going to create a zoom 6 window. And then I'm going to adjust my window to make it look a little bit more like their graph. So when I go to the window, I mean, this is not absolutely necessary. I'm going to change the window, the x minimum, to be maybe negative 0.5. And maybe I'll lower the window. I mean, you don't have to do this, but I'll let my y max be 5 and see what that looks like. Let's change the, again, this is totally unnecessary. I'm just trying to make a better window. All right, so we can see the point of intersection. We don't see the line x equal to 1. We don't have to put that in there. But remember, we do need this point of intersection right here, so the way we're going to do that is a second trace or a second calc, however you think about it. Number 5 is intersection, so enter, enter, enter. Remember that College Board expects that we are going to use that entire decimal number. On our paper, we're going to write 0.239 or 0.238. You can round it or truncate it, but we're going to store that number. So just a reminder of how to do that. You have to be on this graphing screen. Then you're going to press second quit to go to the home screen. Then you're kind of going to come down here right above the on button to store, STO. And you're going to press alpha A, enter. Whoops, what did I do? So second calc 5, enter, enter, enter. There it is. Second quit, store. I don't know what I didn't do before. Alpha, and that happens. So it's a good thing that you saw that. If you don't get your number to store, you have to go back and find the point of intersection again and follow that process. And so now you can see my number has been stored into A. All right, so I'm going to come back now and I'm going to write my integral that I'm going to work with. So notice right here I did have my lower bound 0.239. I wrote it with 3 decimal places to 1. Top curve is the square root of x. Bottom curve is e to the negative 3x. So I'm going to go to my calculator. I'm going to do a math 9 because that is my integration. I'm going to go from alpha a, remember that's my lower bound. Oh, I didn't mean to hit enter. Second quit. All right, let's do that again. Sorry about that. Math 9, alpha a to 1, and I had the square root of x and y number 1, so I'm going to use my shortcut, y1 minus y2. On the AP test, you should not write y1 and write y2. You should actually write the functions like I did on my paper. In terms of x, I don't think I forgot anything. And there's my answer, 0.443 or 0.442. Either of those answers would be acceptable, rounded off or truncated. For letter B, we're finding the volume of the solid generated when the region R is revolved around the horizontal line y equal to 1. So up here you can see that I put in the line y equal to 1. There's clearly going to be a hole in the region because region R is not flush to the line y equal to 1. The line y equal to 1 is parallel to the x-axis, so we're going to be in terms of x because we have a horizontal axis. There's going to be a big R and there's going to be a little r. So you can see that big R is top 1 minus bottom e to the negative 3x. Little r is top 1 minus bottom square root of x. So I have my big R and my little r. The good news is the calculator is going to do all the work. We're going to accumulate the volume from the same points of intersection. So, and remember, now that we're moving from area to volume, now we have pi big R squared, don't forget the squares, minus little r squared. Now I left my answer in terms of pi. We'll talk about both, so let me bring my calculator back up. Let's see if I can slide it over and look at my integral so I type correctly. Yeah. Okay, so this might be okay. All right, so I'm going to do a, so I'll do it first without put. It's dangerous to not put the pi, but I'll not put the pi and talk to you about what's better. So I'm going to do my math 9. I'm going to do integration, and I'm going to go from alpha a as my lower bound to 1 as my upper bound. And for big R, it is 1 minus, in my case, y2. So I'm going to come in here, and I'm going to put my own set of parentheses, 1 minus y2, enter, and I'm going to, whoops, close my parentheses, and I'm going to square that. And then we're going to, that's big R squared minus little r squared. Again, put my own parentheses. 1 minus, I'll do it the other way just for folks who have the older calculator. Vars, arrow to the right, y vars, select function. Select, in this case, y number 1. Close the parentheses. Square the quantity. X, enter, and as you can see, there's my 0.453 3, and I have to remember to put the pi on it, otherwise I'm not going to get the answer point. So instead of trying to remember that, putting the pi on the end, because a lot of times when you're in a stressful situation, you might just record that answer and think you're done. It might be wiser to, I'm going to do my second enter. In case you didn't know this, this will bring back the last thing that I typed. All I did was second and then enter, and it brought it back. I'm going to go back to the beginning, and I'm going to insert a pi in front of this. I'm going to I could have multiplied my last answer by pi. Just lots of things I could do. So I'm going to do right up here where it says INS, insert, second, insert, and then I'm going to insert pi. And that is the decimal answer, 1.423 or 1.424. So you can either have 0.453 with the pi on it, or you can have the pi multiplied in 1.423 or 1.424. All right, so there's your calculator work. That's number 1. Let's go on to problem number 2. And in problem number 2, we have this time. This is a much older problem, but notice that they do not give me the graph this time. Let R be the region, they love the region R, enclosed by the graph of the square root function and the vertical line x equal to 10. This is a square root function that is shifted to the right 1 unit. Also, the x-axis is a boundary region. We're going to find the region of R. So in our calculator, this was probably a non-calculator question back in the day. I mean, this is a really old question. So we're going to get rid of these two. And we'll go ahead and do this with the calculator. So second square root, and it was x minus 1. Remember, we're not going to graph the vertical line and the x-axis. If you want it to, if you have a colorized version of the calculator and you want that to actually be officially graphed, we're going to put the 0 in there. So there's y equal to 0, which is the x-axis. I'm going to go back to a Zoom 6 window, my standard viewing window, and then I can adjust that if I want to. All right, so first we're going to find the area of region R. You can see my graph down below. So if we're finding the area of region R, there's clearly a top curve, the blue, and the bottom curve is red. So we're going to start at 1. We're going to stop at 10 over here and accumulate top minus bottom. So square root of x minus 1 minus 0 just gives me square root of x minus 1. So you can see my setup. Accumulate area. There's no pi in the front. We're accumulating area, not volume, from 1 to 10, square root of x dx, and that turns out to be 18. I'm not going to type that into the calculator for you. I typed in the more complicated one in problem number 1. In part B, we are finding the volume of the solid generated when the region R is revolved, this time around the horizontal line. Oh, it was horizontal before, wasn't it? Yep, so we're still going around a horizontal line, so we will still be in terms of x. And so I drew in the horizontal line. Drawing these graphs is very important for you to see what's going on. So here's my horizontal line, y equal to 3. There's clearly a hole because the region is not flush. So big R is top 3 minus bottom, which is 0. So 3 minus 0 is 3. Little r is going to be top 3 minus the bottom, which is the square root of x minus 1. My lower bound, I can visually clearly see, I don't have to work for it, is 1, and my upper bound is 10 because we are in terms of x. So again, big R is 3, little r is 3 minus square root of x minus 1. When you're putting this in your calculator, be very careful that you put parentheses where they go. So definitely put this in your calculator, make sure you get the right answer, and it's 67.5, which is the same thing, pi, which is the same thing as 67.5 pi, which is the same thing as 212.057058 or 057. Either answer would suffice there. That's number 2. Let's finish it up with number 3. Let's bring my revealer in, insert tools, revealer. Okay, insert, nope, tools, revealer. There we go. So in this problem, here's my, here, come down here with me, even though I have stuff up there. This time we have two different functions like we did in problem 1. Let f and g be the functions given by f of x is 1 plus sine 2x, g of x is e to the x over 2. Let R be the shaded region, the graph is provided up here, in the first quadrant enclosed by the graphs of f and g. Find the area of region R. So when we look at region R, we can see that there's clearly a top curve and a bottom curve, so we're going to find the area in terms of x. We're going to let the calculator find this point of intersection and this point of intersection. This one looks like 0, but you should never assume, students, never assume points of intersection or numbers on a graph given, particularly if there is no grid. So we have a calculator. This is a calculator active question. So we're going to make sure that our suspicions are true. So I'm going to go to y equal to, I'm going to clear that out, and I'm going to type in, why is that there, delete. Okay, so y number 1 is 1 plus sine of 2x, and the second equation is e to the x over 2. As soon as I type sine, I want to check my mode. I should always be in radian mode when I'm doing my calculus work, so I'm going to go back now to y equal to, oops. So e to the x over 2, e is above the ln button, and then I have x over 2, arrow out of there. I'm going to do a zoom 6. And now I'm going to show you a fantastic feature of the calculator that all of you should know and understand. The region that I want is right in here. So I'm going to box it up. The way I'm going to box it up is I'm going to go to zoom. I'm going to select number 1. As you can see, zoom 1 is a box. So zoom number 1. And at the origin, you'll see, regardless of your calculator, you'll see a tiny little blinking plus sign. We're going to use these arrows up, down, right, and left to move the cursor where I want it. I want to capture just this little region right here. So I'm going to move, watch my little plus sign, I'm going to move the plus sign just a little bit, just maybe a couple of ticks to the left. Okay, so I moved it to the left, and when I move it to the left, I'm going to press enter, and you're going to notice that now that little plus sign is like a little blinking X. It's actually a teeny tiny little box. And so I'm going to open the box up, so I'm going to use the up arrow to go higher above what I want to capture. It's kind of like using a mouse. Now don't press enter. Now I'm going to move the box to the, open the box to the right. I'm just capturing the region that I want to blow up or box up. Whoops. Okay, and that captures that point of intersection. And then when I press enter, it's going to set a beautiful window for me based on the box that I created. That's lovely. All right, so now we need this first point of intersection. It clearly looks like 0, but we're going to make the calculator confirm it. So second calc 5. And the calculator always finds the point of intersection that it is closest to. So I moved it closer to the first point of intersection. Enter, enter, enter. And I'm glad this happened because some students are like, wait, what's that number? 1.349e? E is scientific notation. In other words, times 10 to the negative 13. Meaning, move the decimal point 13 places to the left. meaning the calculator's kind of saying, based on the way that the pixels are set up on my screen, I'm trying to tell you this is 0, but I can't really hit 0 because it's a pixel issue. So the lower bound indeed is 0. I'm not going to store that crazy scientific notation number on my paper. I'm just going to write down 0. And then second calc, 5. I'm going to find the other point of intersection. I got to move the cursor closer to the second point of intersection. That's close enough. Enter, enter, enter. Now this point of intersection is not 0. I'm going to store it. And remember, the way we do that is second quit, store, alpha A. Now I realize that we had something stored in alpha A before. It overwrites what's there. So now what's stored in alpha A is 1.136 or 5, or this long decimal number is what's stored there actually. On my paper, I'm going to record 1.136 for setting up my integral. So I have my points of intersection. We're trying to find area. So let's look at my setup. So for letter A, lower bound 0, 1.135. Top curve is the trig function. Bottom curve is e to the x over 2. And the confirmation of that, when I was looking at the graph they provided me, maybe I'm not sure, but when I look at my graph, I should be able to figure out based on the order that it's graphing which function is which. So the trig function is on the top minus bottom. This is area, no pi, no squaring. And so I just thought of a knock-knock joke. Sorry, I got distracted. That's why I stopped talking. So now I'm going to go to second quit, and I'm going to do the integration. So I'll run through that one for you. Math number 9. Lower bound is 0. I'm just going to type that in. Upper bound is alpha A. And now I'm going to have the top curve, which in my calculator is y1. So I'm going to use my shortcut of y1 minus, this makes it so much easier, shortcut y2, top minus bottom. We are in terms of x, and there's no pi. Enter. 0.429 would be the reported answer. You can report more decimals than 3, you just can't report less. So just FYI. And then for part B, we're finding the volume revolved around the x-axis. There is clearly a big hole in this thing. This region is not flush. So when we go around the x-axis, we're going to find big R, and big R is top minus bottom. So it's the trig function, 1 plus sine 2x, minus 0. That makes it easy. So big R is 1 plus sine 2x. Little r is going to be from the inner curve to the axis of revolution, top minus bottom, which is e to the x over 2 minus 0. So little r is e to the x over 2. Let's look at my setup here, if I can get my mouse to come back. So that's how I identified down here, and this time we are finding volume. So there's my pi, my r, big R squared independently. You can't put them together and square them. They're squared independently. Little r squared independently. And I left my answer in terms of pi. But if you wanted the purely decimal answer, you would get, well, but this is round. I hate to give you that answer because it's rounded off. But you would need to put pi in front of your integral, and you could see the purely decimal answer. Maybe I'll type this one in just because it has the squares on it, and it might get a little bit more well, it's not that complicated because you're simply going to do y1 and y2. So what I'm going to do is I'm going to bring back the last integral that I calculated, or my calculator dealt with for me. I'm going to insert, second, insert, and I'm going to put the pi in front. I'm going from 0 to a, same bounds, and big R is y1. I need to square that. Second insert square. Okay, and then I'm going to do same thing here. Second insert a square. Let me make sure I have that correct. So y1 quantity squared minus y2 quantity, big R squared minus little r squared. Now I'm going to get out of there, enter, and your purely decimal answer is 4.266 or 4.267. That would be accepted as well. And I think that's all for these free response questions. So hopefully you've done these 3 reviews, you feel good, and you're ready for a test.